All right, welcome back. If you did the other videos on how to solve trig equations, these are going to be some more advanced ones. Now, solving trig equations can be quite difficult, so if you found those other ones difficult, that's to be expected. These are actually worse. So, unfortunately, they can just be tricky. Now, maybe you watched the other ones, you didn't think they were that bad. These will still ramp it up a bit. So these are some of the hardest things we do in the course. Uh, Not, once again, the best thing to do on a video, but we have no other choice, so I'll do my best. So I'm going to go over two problems that are trig equation problems that are a little more advanced than the ones we did before. The first one is this one that actually has a mix of trig functions in it, which can be difficult because it doesn't just have sine, it has sine and tangent. So it's basically sine x times tan x has to equal sine x. So we have to find some angle that when we do sine times tangent gives us the same result if we put that angle in the sine function. Good news is at least they don't want it in terms of radians. We can leave it in terms of degrees. So to do this, that step that I did where we replaced the trig functions with letters is going to be handy here because it'll let us see the structure of what we need to do. Basically, we're going to replace these with letters and then set it equal to 0 and use some factoring. In fact, both problems I do are going to require setting it equal to 0 and doing some solutions that way, either using factoring or you'll see in the next one, the quadratic formula. So here is the solution to this problem. There are actually 4 answers that you get. So the reason you get 4 answers is because you get 2 separate equations. So if we don't focus on the trig right now and just focus on solving the equation itself, notice that I made my let statements. I let s be sine x and t be tan x. That way I could make that complicated equation look a little less complicated. So instead of it being sine x tan x equals sine x, I'll just use the letters. I'll just make it s times t equals s. Now how do I solve s times t equals s? If you go back to algebra, you could solve this by factoring if you get it equal to 0. So I noted I'm going to get this equal to 0 and then factor out the common s that they share. So the way I'm going to solve this is subtract the s over, get st minus s equals 0. And then since they both share s, I can separate the s out, pull it out of both of them. Now, since I have 2 factors, when you learn about factoring in algebra, you can set each factor equal to 0. So I can make one equation where s equals 0 and another equation where t minus 1 equals 0. So either s equals 0 or t minus 1 equals 0. If I solve s equals 0 by replacing the trig function, it's already solved. It basically says sine x equals 0. I'm going to have to go back and find x, but that equation's ready to go. This one, I want to add the 1 over to get the t by itself. So remember, I want to isolate those variables. Once I get t by itself, I get t equals 1, which I replace the trig function. I get tan x equals 1. So I have 2 equations I need to solve for x. One of them is sine x equals 0. One of them is tan x equals 1. The solutions to those will be the solution to this. Now, how do I find those two? The problem with sine x equals 0 is you can put that in a calculator and do the inverse, but it'll only give you the one solution. It'll only give you 0. It won't give you the 180. You have to realize that these usually have more than one solution. Now, you can't do the quadrant trick on this because these are on the borderlines of the quadrants. But this is where it helps to really know your trig values and know the unit circle, because basically you got 2 spots. So remember, sine is the height of the angle. There are 2 angles that have a height of 0, because it's asking what angles have a height of 0. The calculator will tell you 0. The calculator won't give you the 180. So you have to realize that there's 2 angles that have a height of 0. The 2 angles that have the height or sine of 0 are 0 and 180. Now 360 also does, but they don't include 360 up here. Basically, we go up to 360 but not include it. So I only have 2 answers, 0 and 180. So that solves the first one. And basically, I did that by knowing how to use the unit circle. Tan, I can use the calculator for, because basically tan x equals 1 tan inverse of 1. Now, if you're really good with your table values, you might already know this is 45. If you stick it in a calculator, it'll tell you 45. So you basically get that the reference angle is 45. Now, keep in mind for this one, there are two answers because there's an answer in quadrant 1 and an answer in quadrant 3. So if I made the diagram again, the calculator gives me the quadrant 1 answer 45, but tangent's also positive in quadrant 3 according to the stack diagram. So I need an answer down here. The way I'm getting that answer is by doing 180 plus the reference angle. So this is the reference angle. That second answer comes out quadrant 3. That's found by doing 180 plus that 45. So that's 225. So now I have a total of 4 solutions. 2 things solve the first equation. 2 other angles solve the second equation. Basically, anything that solves this one or this one is an answer. So I get 4 answers. That original equation, so how do I make sine x times tan x equal to sine x? If I plug in 0 degrees, 45 degrees, 180 degrees, or 225 degrees, that equation should work, and I should get the same solution. All right, so that's solving one. That's more difficult due to the factoring. So this end part's pretty much the same as we did before, but this part is a little different because solving the equations a little more advanced, and you get 2 separate equations. Now for the big one. So if you can get this example, you could probably do any of them. This is a trig function that's also quadratic. Because basically you have a cosine squared and a cosine, and it's equal to a number. So they're looking for what angle could I put in that if I take its cosine and square it, multiply it by 6, subtract it by 5 of the cosine of that angle, I'll get 3. Now this one is really annoying because not only is this going to take a while to solve, but I have to put the answer in radians. So try to follow this as best you can. Let me put up the answer. So here's the solution. The left side is solving the equation and not doing the trig part of it. I don't do the trig part to the right side. So the first thing I started by doing was replacing cosine with c. Now, it's handy to do here because it lets you see that it's a quadratic equation. So I'm going to let c equal cosine. So then 6 cosine squared just becomes 6c squared. 5 cosine becomes 5c, and the 3 is still 3. So notice it makes it simpler to look at. Instead of seeing the trig functions, it hides the trig function, and you see that it's a quadratic equation. It's 6c squared minus 5c equals 3. When we solve quadratics, we get them equal to 0. So I got it equal to 0. 6c squared minus 5c minus 3 equals 0. Now, I decided to do a harder example. In an easier example, the thing would factor, and you'd be able to solve it like we did before by just using factoring and getting 2 separate equations. In this case, I tried the X puzzle, and factoring didn't work. So in a last-ditch effort, you can solve any quadratic equation. If you can't factor it with an X puzzle, you use the quadratic formula. So I put that there. Use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when I wrote it, I didn't want to write that all out. So notice that normally it's x equals. Our variable is not x, it's c. So the quadratic formula is going to be c equals. This is negative b squared 4ac over 2a. Simplifies to this, and I just threw this into the calculator just to get the decimals so it was easier to write over here. You could leave it this way and do the inverse in the calculator, but basically I figured decimals would be easier to look at for this. So the exact answers are 5 plus or minus radical 97 over 12, but it's easier to look at them as decimals. One of the answers is that c has to be 1.237. The other one is that c is negative 0.404. Now, once again, I've got 2 different solutions, so c is either this one or the other one. Remember, c means cosine, so after you solve the equation, I isolated the variable. I have to put the variable back, so c was cosine, So that means cosine x is either equal to 1.237 or cosine x is equal to negative 0.404. Now, the one on the left is actually nice because remember, cosine can't get bigger than 1. So if you try to take cosine inverse of something bigger than 1, you get no solution. So the first equation actually has no solutions, which is nice because we don't have to do anything else to it, but we can just stop there. Now, the other equation, though, does have answers to it because this one, if I do cosine inverse in the calculator, I'm doing cosine inverse of something negative, so it's going to give me a quadrant 2 angle. So hopefully you remember that from the video on inverse trig functions. Now, there's more than one solution. This is only one of the solutions, so I have to go back and find the other. So the one solution I have is the quadrant 2 angle of 113.828. I need to get the other angle, which is 246.172. Now, how do I get the quadrant 3 angle? And basically, how do I know which quadrants? Well, I'm doing cosine inverse of something negative. Cosine's negative, according to the stack diagram, in quadrant 2 and quadrant 3. So I basically need an angle out of each of those quadrants. The calculator gave me the quadrant 2 angle, but the way I get the quadrant 3 angles, remember, I need the reference angle. I did this in the last video. In order to get the reference angle, I have to do 180 minus this quadrant 2 angle. If I do 180 minus that angle, it gives me that 66.172. So that's how I got this reference angle. And then to get the quadrant 3 angle, I basically need to do 180 plus that reference angle. So 180 plus the reference angle came out as 246.172. So it's a decent amount of work and thinking, but if you're able to handle that, then you get the two solutions. What solves this problem in degrees is 113.828 degrees and 246.172 degrees. But the last annoying step is they didn't want degrees, they want radians. So to convert from degrees to radians, you have to multiply by pi over 180. So I basically took these two things, put them in the calculator, and just multiply them by pi over 180. That converts them to radians. So in radians, one of the answers is approximately 1.99 radians. I rounded them to the nearest hundredth. And the other answer is 4.30 radians, once again rounded to the nearest hundredth.